Hi friends, this is Denario Research and welcome to the third part of XRP payments in Codius contracts video series. In this video series we implement XRP smart contract. Last time we have completed payments module implementation and today it's refunds module time. Let's quickly go through its algorithm. Firstly, we check delivery status. If delivery is not in progress already, we simply stop model. If it's still in progress, we check whether our 30 minutes guaranteed time has expired or not. If not, we check delivery again. If time has expired, we are picking transaction from the history, constructing new transaction from it, signing it, and sending back to sender. This is our source code in index.js, and here is implementation of payments model. For the sake of simplicity, let's assume that XRP is a horrible company and it refunds all transactions it receives. So to do this, let's add some timeout, set timeout, let it be 10 seconds for instance, and inside this timeout we'll type only one function, issue refund. And this function will have two parameters. The first one, of course, is source address, which would be in case of this function destination address. And the second one is amount, of course. So let's copy this value too and paste it here. So how does it work? When we pay for pizza, this model receives transaction, it waits 10 seconds instead of 30 minutes and sends transaction back. So now let's implement issue refund function. Let's go to the bottom of the file here and create function issue refund. It has two parameters. First one is to address and second one is amount. Okay, the first thing we'll do is to update status. So let's copy this part and edit it. We will not send transaction ID and all other stuff. We will simply update message like delivery failed, issuing refund. Okay. Now we can construct XRP transaction, but there is only one thing missing here: sequence. All XRP transactions are ordered, and sequence is simply the number of the next XRP transaction. We can get this sequence number from getAccountInfo function. Because we are already connected to XRP testnet, we can simply type API getAccountInfo, then info, of course, and implement callback. And of course catch errors. Catch console error. Okay. Now we can construct transaction inside of this callback. So let's create variable, call it transaction. It would be JSON object, and first key pair is transaction type. Transaction type. In our case, it is payment. Payment. Then we need to provide sending account. Account is our address. Next comes destination account. Destination is our to address. to address. Okay. Now let's provide sequence equals to info.sequence sequence. Okay. Then comes fee. Let's hard code its value, and it would be 12 drops, but it should be converted into string. So let's make this trick. And finally, let's provide amount. Amount equals to our amount value, but it has to be in drops as well. So it multiply by 1 million. And also convert into string. Here is our transaction. The next step is to stringify it and sign. So let's create another variable and call it txJSON equals to JSON stringify our transaction. And another one, so let's add let here, and another one variable, let tx signed equals to API sign txJSON, and here we need to provide our secret key. So I'll copy it here. This key is a secret key from XRP account, and I want to comment this part before we move further. When you upload contract with key inside to the Codius host will be able to see it, and this may be a big security issue. So do not upload contracts with keys to host you do not control. Well, once transaction is signed, we are able to submit it to XRP ledger. So API submit tx signed transaction. Then some callback with one parameter. Data will implement this callback and catch errors. Catch console error. Okay. Let's implement callback now. Firstly, let's console log data to see what's inside. Console log data. Transaction submission does not guarantee its validation, so let's create some sort of mechanism that will check ledger and find out whether our transaction is validated or not. We'll do this in the similar way we implemented payments model. Let's create some variable and call it check transaction, and this variable equals to setInterval function, and here comes callback, and with interval 1 second, which means we'll check ledger every second. Inside this callback, let's make console log message, something like checking transaction result. Okay. And we'll use getTransaction function to pull it by ID from ledger. So API get transaction tx signed dot ID is ID of our signed transaction. Then callback data and catch errors, of course. Catch console error. Okay, let's implement this callback. Once we find transaction on the ledger, We'll clear interval, our check the X, and we'll console log data. This is it. Here is implementation of payment refund model. Now let's check it. Save code, of course. Let's launch application, node index.js. Okay, let's wait for connect to testnet message. Fine, now let's send test transaction. Node test send. And let's see what happens. Well, test transaction is successfully sent. Then we wait 10 seconds and we'll send transaction back. Okay, we have an error and let's fix it. Of course, I forgot to put address parameter into getAccountInfo function. So let's add it and try again. Let's launch application again and send test transaction. Okay. This test send message file works in the same way as we have implemented refunds model. So test transaction is successfully sent. Now let's switch to this window and see its results. So firstly we see transaction sent result, submit result, sorry. So result code is test success and message that transaction was applied to ledger, but it is not validated yet. And here is validation process. Finally, when transaction is on the ledger, we can pull it by ID and we see these transaction details. Type, address, sequence number, transaction ID, from address to address, and if we dig deeper, we'll see amounts. And again, transaction result success, date and time when it was submitted to ledger, and balance changes between this account. And finally, let's do one more thing. Let's update status message in browser. So let's copy this IO emit part and paste it inside of get transaction callback. So once transaction is validated, we'll send message that refund was successfully delivered. Okay, amount plus amount plus was sent to plus to address. Okay, now let's save file and create Docker image. Here is Docker file we'll use for our image. I have copied it from how to create Codius contract video. If you did not watch it, I recommend you to do so, because since all next steps I have already explained in that video, I'll skip them until Codius contract upload part. Well, I have created Docker image, uploaded it to hubdocker.com, and also created manifest file. Now let's upload this manifest file to some Codius host. Okay, let's save this one. And Codius upload host. I'll pick some of mine host. HTTPS Codius Denario Research XYZ, and duration, let's 20 minutes. Okay, let's hit enter. I have to remove state from my previous upload and try again. Okay, here is our manifest file again, and hit yes. Well, contract is uploading. Contract is finally uploaded. We have its URL, so let's copy it and paste it into browser window. Here is our XRP on Codius. As you see, interface looks the same and it is waiting for payment. Okay, now let's send test transaction. Send in transaction. Okay, payment was received. Now we wait 10 seconds and send payment back. Delivery failed issuing refund. And 20 XRPs was sent back to the sender. Great. Thumbs up if you like this video, subscribe to my channel if you want more videos, and leave your questions in the comment section below. Bye.